Good morning everyone. Ladies and gentlemen, welcome to our video presentation on one of the most groundbreaking experiments in the history of physics, Thomas Young's double-slit experiment. This experiment, conducted over 2 centuries ago, has had a profound impact on our understanding of light and the nature of reality itself. Through careful observation and analysis, Young was able to reveal the wave-like nature of light and pave the way for the development of quantum mechanics. Join us as we delve into the fascinating details of this experiment and its implications for modern physics. Let's explore the mystery of light and discover the profound insights that Thomas Young's double-slit experiment has to offer. Sure, I'd be happy to explain the Thomas Young double-slit experiment in detail. The double-slit experiment is a fundamental experiment in physics that was first performed by the British scientist Thomas Young in 1801. The purpose of the experiment was to study the wave-like nature of light and to investigate whether light could behave like a wave or a particle. To conduct the experiment, Young set up a screen with 2 narrow parallel slits in it and placed a light source behind the screen. When light was shown through the 2 slits, it created an interference pattern on a second screen placed some distance away. This interference pattern consisted of a series of bright and dark bands, or fringes, which indicated areas of constructive and destructive interference between the waves of light passing through the 2 slits. Young's experiment provided strong evidence for the wave-like nature of light, as the interference pattern created by the light passing through the 2 slits could only be explained by waves interfering with each other. The experiment also provided evidence for the concept of superposition, which is a key principle of quantum mechanics. Superposition is the idea that particles can exist in multiple states at the same time, and the interference pattern created by the light passing through the 2 slits suggested that light waves were interfering with each other in a way that could only be explained by the concept of superposition. One of the most interesting aspects of the double-slit experiment is the fact that it can be used to investigate the duality of light, which means that light can behave like both a wave and a particle. When the experiment is repeated with a detector placed behind the slits to detect which path the individual photons took, the interference pattern disappears and is replaced by 2 distinct bands, which suggest that the photons are behaving like particles. The Thomas Young double-slit experiment is one of the most important experiments in the history of physics, as it provided crucial evidence for the wave-like nature of light and paved the way for the development of quantum mechanics. It is still studied and replicated today, and continues to provide insights into the fundamental nature of light and the universe itself. Thomas Young's double-slit experiment played a significant role in the development of quantum mechanics, which is the branch of physics that describes the behavior of particles on a very small scale, such as atoms and subatomic particles. One of the key aspects of the double-slit experiment is the interference pattern that is created when light passes through the 2 slits. This interference pattern is the result of the waves of light interfering with each other, and it can only be explained by the wave-like nature of light. However, the experiment can also be used to demonstrate the particle-like nature of light. When detectors are placed behind the slits to determine which path individual photons take, the interference pattern disappears, and the photons behave like particles. This duality between the wave-like and particle-like behavior of light is one of the key principles of quantum mechanics. In quantum mechanics, particles can exist in multiple states simultaneously, and their behavior is described by wave functions that predict the probability of observing a particular outcome. The double-slit experiment also demonstrated the concept of superposition, which is another fundamental principle of quantum mechanics. Superposition refers to the idea that particles can exist in multiple states at the same time. In the double-slit experiment, the interference pattern is created because the waves of light passing through the 2 slits interfere with each other in a way that can only be explained by superposition. Furthermore, the double-slit experiment has been extended beyond light to other quantum particles, such as electrons. Just like light, electrons can behave like both waves and particles, and they too create interference patterns when passed through a double-slit setup. This demonstrates the fundamental nature of wave-particle duality that applies to all quantum particles. Overall, Thomas Young's double-slit experiment provided important evidence for the wave-like nature of light and paved the way for the development of quantum mechanics, which has since become one of the most important branches of physics. The experiment continues to be studied and replicated today, and it remains a crucial tool for investigating the fundamental nature of the universe. Thomas Young performed the double-slit experiment in 1801 to study the nature of light and investigate the phenomenon of interference. At the time, there were 2 dominant theories about the nature of light: the wave theory and the particle theory. The wave theory, which had been proposed by Christian Huygens, suggested that light was a wave that traveled through a medium called the luminescence ether. This theory could explain some of the phenomena of light, such as refraction and diffraction, but it had some limitations in explaining other aspects of light. The particle theory, on the other hand, which had been proposed by Isaac Newton, suggested that light was made up of small particles or corpuscles that traveled in straight lines. This theory could explain some of the phenomena of light, such as reflection, but it had limitations in explaining others. Young was interested in testing these theories and resolving the debate about the nature of light. He set up an experiment with a screen containing two narrow parallel slits in it, and placed a light source behind the screen. When the light was shown through the two slits, it created an interference pattern on a second screen placed some distance away. This interference pattern consisted of a series of bright and dark bands, or fringes, which indicated areas of constructive and destructive interference between the waves of light passing through the two slits. Young's experiment provided strong evidence for the wave-like nature of light, as the interference pattern created by the light passing through the two slits could only be explained by waves interfering with each other. This was a significant development in the understanding of the nature of light and helped to establish the wave theory as the dominant theory of light. In addition to its importance in the history of science, the double-slit experiment has had many practical applications, such as in the development of technologies that use interference patterns, including holography and diffraction gratings. In summary, Thomas Young performed the double-slit experiment to investigate the nature of light and resolve the debate between the wave theory and the particle theory. His experiment provided strong evidence for the wave-like nature of light and helped to establish the wave theory as the dominant theory of light. The wave-particle duality is a fundamental concept in quantum mechanics that refers to the fact that particles can exhibit both wave-like and particle-like behavior under certain conditions. This concept arose as a result of experiments that showed that particles, such as electrons, photons, and other subatomic particles, can exhibit both wave-like and particle-like behavior, depending on how they are observed and measured. In classical physics, particles are thought of as discrete, localized objects with definite positions and velocities, whereas waves are thought of as continuous, spread-out disturbances that travel through space. However, in the microscopic world of quantum mechanics, particles can exhibit wave-like behavior, such as diffraction and interference, and waves can exhibit particle-like behavior, such as quantization and discreteness. One of the key experiments that demonstrated the wave-particle duality is the double-slit experiment, which was first performed by Thomas Young in the early 19th century. In this experiment, a beam of light or a stream of electrons is passed through a barrier with two small slits. When the particles pass through the slits, they interfere with each other and produce an interference pattern on a screen placed behind the slits. This interference pattern is characteristic of wave-like behavior and indicates that the particles are behaving as waves. However, when the experiment is repeated with detectors placed at each slit to determine which slit the particles pass through, the interference pattern disappears and is replaced by a pattern of two distinct bands. This is because the act of measurement collapses the wave function of the particles, causing them to behave like particles with definite positions. The wave-particle duality is not limited to light and electrons, but applies to all particles, including atoms, molecules, and even larger objects, such as viruses and cells. The behavior of these particles can be described by a mathematical framework known as quantum mechanics, which uses wave functions to describe the probability of finding. Thomas Young, 1773 to 1829, was an English scientist who made significant contributions to a wide range of fields, including physics, optics, linguistics, and medicine. He was a polymath who excelled in many areas of science, and his work laid the foundation for some of the most important discoveries of the 19th century. Young was born in Melbourne, Somerset, England, on June 13, 1773, to a Quaker family. He was a precocious child who was educated at home until the age of 14, when he entered Emmanuel College, Cambridge. He graduated with a BA degree in 1794 and an MD degree in 1796. After completing his studies, Young began practicing medicine in London, but he soon became interested in science and started to conduct experiments in his spare time. He made significant contributions to the fields of optics and physics and is best known for his double-slit experiment, which demonstrated the wave-like nature of light. He also contributed to the development of the theory of color vision, showing that the eye has three color-sensitive receptors. Young's work in linguistics was also groundbreaking. He is known for his contributions to the decipherment of the Egyptian hieroglyphs, which he was able to partially translate by comparing them to the Greek alphabet. He also proposed the concept of the Indo-European language family, which is now widely accepted. In addition to his scientific work, Young was also a physician and made significant contributions to medicine. He was the first to describe the condition now known as astigmatism, and he made important contributions to the understanding of the human ear and voice. Young was a member of the Royal Society and received many honors during his lifetime, including the Copley Medal in 1827. He died in London on May 10, 1829, at the age of 55. Overall, Thomas Young was a brilliant scientist who made significant contributions to a wide range of fields. His work laid the foundation for many of the most important discoveries of the 19th century and continues to inspire scientists today. Goodbye.